Hello students, good afternoon all of you. So today we are going to discuss about wave optics part 2. Last class we discussed already part 1. In that I have given so much of information, that is, what are the theories of light. That is the first question I have given. And second question I have given, what is wavefront? What is wavefront? This and all. In the introduction topic only, I have given this and all. What is that? What are the theories of light, as well as what is wavefront and types of wavefront. This and all I have given. So that is the first one. That means introduction topic. Now second topic is very important topic, that is Huygen's principle. What is Huygen's principle? Yes, yesterday I have given Huygen's wave theory, correct? Huygen's wave theory. So Huygen's wave theory we discussed so many points, and also he explained reflection, refraction, all those things. So today we are going to discuss about. So first question is Huygen's principle. Next one. So what is the reflection? What is the reflection according to Huygen's, and what is the refraction according to Huygen's? So these three concepts we can learn today itself. Right? Okay. So first one. The first one is Huygen's principle. First one is what? Huygen's principle. Right. Huygen's principle. What is Huygen's principle? Very important mark. This is a compulsory 2-mark question. So everybody listen carefully and remember these 2 points. Very easy points. So first point. What is the first point is given? So according to Huygen's principle, each point on a wavefront, acts as source of secondary disturbance, which emits their own wavelets, are called secondary wavelets. These wavelets spread in all directions with the speed of wave. This word is very important point. This one. What is that? Speed of wave. Right. What is the first point here? Each point on a wavefront acts as source of secondary disturbance. Which emits their own wavelets, are called secondary wavelets. These wavelets spread in all directions with the speed of wave. Very important point. Understood everybody? So what is that? Each point on a wavefront. Remember this word. Each point on a wavefront acts as source of secondary disturbance, which emits their own wavelets. So new word, wavelets, are called secondary wavelets, and these wavelets spread in all directions with the speed of wave. For example, speed of wave is v, mean the speed of wavelets also v. The speed of wavelets also v. That is the first point. Very important point. So next, second point. What is second point? The common tangent on secondary wavelets. The common tangent on secondary wavelets in forward direction gives a new wavefront. Gives a new wavefront. What is that meaning? Yes. So for example here I have, first I will consider point source. Okay. So now I have, this is the point source. Point source, that means so primary source. Primary source of wave. Primary source of wave. So that now, so what happened here, from this point, from primary source to some waves can move in this direction. Waves, not only one direction, in all direction the waves can spread. The waves can move. Yes. I took that. So four positions, right? So what is the wavefront? Wavefront is nothing but, so we want to consider, so as the same phase. We want to consider same phase on each wave, right? So this is, I will, for example here I will consider, so first point A, and there is a crust, right? Here also crust. So this is the point B, and this point C, and this is the point D. Point D. So wavefront is nothing but, so same phases we want to join with the help of one line. That is known as the wavefront. Correct or not? Yesterday I given. So locus of all points together. Locus of all points together, right? So I can join this line. B to A, again A to D, A to D. So crest, trough, and crest. Okay. So B to C, that exact equal circle will come. Why? Because so phases are equal only, na? The distance is same. The distance is same. The distance is same. Are you clear? So this is, what is this? So phase, sorry, wave front. This is the wave front. The locus of all points we can join with the help of one line, one circle. So this is nothing but so concentric circle, concentric sphere, not circle, sorry, concentric sphere. Is a concentric sphere, right? So this is the, so what is that? So primary wavefront. This is the primary wavefront. Primary wavefront. Now I can remove this so waves. I can remove this source. Sorry, waves. Right? So this is the wavefront. Is the wavefront. Now I can draw again this circle, the sphere. So this is the primary wavefront. How I drawn? I given that explanation. So this is the P. What is the meaning of P? P is equal to primary source. Primary source. Right. So what is this line? This like this sphere. That sphere is nothing but, this is the wave front. Wave front. Primary wave front. First wave front. First wave front. Right. So now I took there here one point. Yes, sir. A point. This is the B point, and this is C point and D point. Right, this is the C, A, B, D, correct? So this is the A and B and C and D I have given. You can observe once again. What is that? Each point on a wave front. Each point on a wave front. That means, so at A, B, C, D. This is the A, B, C, D. Is the point on wavefront. Correct? Point on wavefront. So A is the point on wavefront, B is the point on wavefront, C is the point on wavefront. D is the point on wavefront. I took there A, B, C, D, some point. So many points also will be there. But I took there only 4 points. Right? Nothing will happen. Right. Next. This points A, B, C, D. That points acts as source of secondary disturbance. These points acts as source of secondary disturbance. That means this the A point is the secondary disturbance. So B is the secondary disturbance. C also, D also. These all points are secondary disturbance on the primary wavefront. That means this is the secondary disturbance. Secondary disturbance. Secondary disturbance again it will give waves. Again it will give us wave disturbance. The disturbance is nothing but wave only, right? The disturbance in the medium is known as wave. So that here again what happened here? So the waves can move in this direction. So crest, trough, crest like that one is the secondary disturbance. Secondary disturbance. R is source of secondary wavelets. Secondary wavelets. Right. So now I will consider from here to a same x distance. After time t 1 seconds. From here to here, the wave can move, right? Previous from here to here, I have given some time. Yes or no? Some distance. At the same time, here also I will consider from here to here, somewhere here, or somewhere here, here, and crest. Yes or no? Trough and crest. So again here crest and trough. What is that? So crest and crest, trough and crest. So here also crest and crest. And crest and crest. Yes or no? So this point again. These all points we can join together. Locus of all points. Yes. That is. Similarly here also. Similarly here also. Did you understand? Are you following? Yes. Are you clear, man? So what is the point here? Acts as a source of secondary disturbance. Secondary disturbance which emits their own wavelets. Their own wavelets. See, this is going like that one. So this is the spread. It can spread. So I given that word also. What is that? Wavelets spread in all directions. So this is the moving in this direction. Is the moving in this direction. Is the moving in this direction. So like that. And in this manner, in this manner, in this manner. So it is a moving like that. Yes or no? So now I can draw. So one common point. So that what is that? So here we have same face, here we have same face, here same face, same face. Same face, same face, same face, same face. Right? So now here, from here to here, I can draw one arc like that one. So one arc. Here also one arc. Here also one arc. So here also one arc. From here to here. So this is the distance will come. Here to distance will come. Here to distance will come. So this is the distance. That means here is a secondary source. This is a what? Secondary source. Source of secondary disturbance. What is point? Source of secondary disturbance. Secondary disturbance. This point also source of secondary disturbance. Source of secondary disturbance. Source of secondary disturbance. Wherever you see. So now this is this one hemisphere. From here to your hemisphere. Again from here to here again hemisphere. So this sphere is known as a wavelet. Wavelet. That sphere is known as a wavelet. So again here one sphere. This sphere is known as a wavelet. This sphere is known as wavelet. This sphere is known as a wavelet. Remember everybody, very important point. What is that again? Each point on a wavefront, each point on a wavefront acts as a secondary, act as a source of secondary disturbance, source of secondary disturbance, and which emits their own wavelets. That secondary disturbance emits their own wavelets, right? So this is the waves are going in this direction, So this is the wavelets. So now I can draw here. So here the same phase, that all points I can join with the help of such sphere. So I got one of a wavelet. This is known as wavelet. That is known as wavelet. Are you clear everybody? So wavelet, already written here, is a wavelet. Next, the distance between from B to B dash, A to A dash, D to D dash, as well as C to C dash. So what is that? B to B dash is equal to C to C dash. That means name only. Yes or no? So B to B dash are, A to A dash are, D to D dash are, C to C dash. So that is nothing but, so distance traveled by wavelet. Distance traveled by wavelet. How much, sir? So that the distance I will consider, so d distance. Here to here, how much distance I will consider? D distance. D distance. D is equal to, what is the D? D is equal to velocity into time. Velocity into time. Correct or not? So velocity into time. Time I will consider T1. What is the meaning of T1? Where T1 is equal to, remember this point I can rub my here. So this is the first point, very important point. Okay, so again last and final. Each point on a wavefront act as source of secondary disturbance which emits their own wavelets are called secondary wavelets. These wavelets spread in all directions with the speed of wave. Speed of wave. Very important point, that is speed of wave. Right. So now I will consider after time t. After time t, distance traveled by wavelet. Wavelet d is equal to v into t. This one I will cut t1 time. T1 time I will consider tau itself. Therefore, here what will come here? D is equal to v into tau. V into tau. What is the meaning of D? Distance traveled by wavelet. Distance traveled by wavelet in t1 seconds. T1 seconds. Similarly, for example, so again here, this point and this point and this point. We can observe second point. What is that? The common tangent on secondary wavelets. Secondary wavelets. That means this is the source of secondary disturbance is gives to secondary wavelets. This is called secondary wavelets. Secondary wavelets. The common tangent on secondary wavelets in forward direction. In forward direction is gives a new wavefront. A new wavefront, right? So what is that? This is a common tangent I can draw here. So envelope. So forward envelope. So is a forward secondary wavefront. Similarly, backward secondary wavefront also will be there. So that is how we will consider like that here only. But this point, they neglected. Why? Because so this is again. So very near will come, right? So that is a negligible. So we want to consider that is. So now we will consider here secondary wave front. This is secondary wave front. This line. So this is a common tangent. Is a common tangent sphere. Is a common tangent sphere. Is nothing but a secondary wave front. After, remember, after time t1 seconds, t1 second is equal to tau. T1 second is equal to tau. So t1 second after the wavelet can travel this much distance. This much distance. After t1 seconds, the wavelet can travel from here to here. The distance is known as v into tau. V into tau. Now we draw common tangent. Common tangent. The common tangent is gives new wavefront. Is a new wavefront. So similarly, again according to first point, each point on a wavefront acts as a source of secondary disturbance. Again here. So this is a disturbance, again disturbance, again disturbance, disturbance. Again what happened here? So again waves can travel. So again wave travel, again wave travel in this direction. Secondary disturbance. That means again disturbance here. Again disturbance. Again we want to draw so one sphere with the same face. With the same face. Here again, here also again same face. Is the again what is that? Wavelets, secondary wavelets after t2 seconds. After t2 seconds. So this is covered from here to here again distance from here to here. So this is the d. So v into t2. Velocity is same. Why? Because here same medium is gives same medium is having same velocity. So velocity does not change. That's what we are saying. What is that? The speed of wavelet is equal to the speed of wave. The speed of wavelet is equal to the speed of wave. Why? Because the medium is same. The medium is same. So that here I get distance. So what distance? After t2 seconds. T2 second distance d. D is equal to formula v into t2. V into t2. Again we can draw common tangent. Common tangent. This is the, so again wavefront. Again wavefront after t2 seconds. After t2 seconds. So again one more wavefront. This is a primary wavefront. This is a secondary wavefront. This is again third wavefront. Again fourth, fifth, so on like that. The wavefronts can form. Alright. So now I can draw. So simple line diagram. So this is another I have given. Right. So what is that? So first one here. Listen everybody. So this is the point. Primary source. So now this is the, what is that? First wavefront. Primary wavefront. Primary wavefront. Right. So again here is the secondary wavefront. Mean, so here one circle, here one circle, here one circle, here one circle, so sphere, sphere, What is the spheres? What is the sphere? Right. This is the so. What is this? Source of secondary disturbance. Source of secondary disturbance. So listen everybody again. This is the source, primary source. This point is what? Yes, means source of secondary disturbance. Secondary disturbance is gives secondary wavelets. Secondary wavelets. So that means this is the this is spheres. So this spheres is what? Secondary wavelets. Secondary wavelets. Alright? Secondary wavelets. Now we can draw common tangent. We can draw common tangent. It's a common tangent. Common tangent. Right? So this is a common tangent. So this is nothing but secondary wavelets. Secondary wavelets. Secondary wavelets. So from here to here distance is same. From here to distance is same. Same distance. Same distance. Same distance. Same distance. Remember everybody. Same distance. Why? Because I took there with the same phase. Correct or not? With the same phase. From here to here, same phase. Same phase. Same phase points. We can locus. That is the wavefront. Again, similarly, from here to here, from here to here, from here to here, here to here, same phase. Everywhere I will get the same phase. So now I can draw here circle. But one condition remember here, the secondary wavelets we can represent it as a sphere. Secondary wavelets. Secondary wavelets we can represent it as a sphere. This word is most important. Secondary wavelets. Right. So this is the pH source. Primary source. Last and final. S is the source of secondary disturbance. Secondary disturbance. And this one, this circle, this sphere. This sphere is nothing but a wavelet. Wavelet. This sphere. This sphere is nothing but secondary wavelet. Okay, secondary wavelet. And this common tangent. This common tangent is known as secondary wavefront. Secondary wavefront. This is the Huygen's principle. These 2 points together, which one? First point and second point together, we can call it, that is the Huygen's principle. Did you understand everybody? Huygen's principle. So how much distance from here to here? So here to here distance is d distance. So d distance. So d is equal to after. So time t1. So t1 I took there only. So this is the Huygen's principle. Very important principle, man. That's it. This is the Huygen's principle. Did you understand? So what is that? Each point on a wavefront act as a secondary disturbance, source of secondary disturbance, which emits so wavelets, which emits, what is that? Which emits their own wavelets. Their own wavelets are called secondary wavelets. Secondary wavelets. These secondary wavelets can spread so every direction with the speed of wave. With the speed of wave. This point is very important. Remember everybody. Right. So next. So now this wavelets are happened. Now we can draw common tangent on secondary wavelets. Common tangent on secondary wavelets in forward direction. In forward direction. So gives new wavefront. New wavefront. That is the secondary wavefront. Secondary wavefront. This is the principle of Huygens. Did you understand, everybody? Very important 2 mark question mark. Alright, now we will enter into second question, third question. That is what is the reflection and refraction according to Huygens? How he is proved? He is a proof. He is the given proof. The laws of reflection, the laws of refraction. You know, laws of reflection as well as laws of refraction. Right? This is the given. So according to Huygens, how he given, we will see once. Right? Okay. Right now, one more point I missed out there. What is that? This is the point source. This is the point source. Similarly, plane source. That means plane wavefront. How can we draw wavefront with help of plane wavefront? Plane wavefront. Right. So, plane wavefront. We know already. What is the plane wavefront? So, this is the from infinity. The source of waves are come from infinity. So, in this direction, this is the plane wavefront, that means incident rays. Yes or no? So now this is plane wavefront. Is the plane wavefront. Plane wavefront. That means here is a crest like that one. Correct or not? So crest like that will be there. That means this is the plane wavefront. Now I will consider each point on wavefront is gives secondary wavelets. Secondary wavelets, right? So now I will consider this is what is that wavefront? As a primary wavefront, is a primary source. Now this is the primary wavefront. Is the primary wavefront. Now I will consider points on wavefront. Points on wavefront. Each point act as a source of secondary wavelets. Source of secondary wavelets. Right. So now secondary wavelets. Secondary wavelets is nothing but again here transferred in this direction, this direction. So secondary wavelets can form circle. Correct or right? Yes or no? So here this is a secondary. So here to distance time t1. So again here to here. So time t2 seconds. From here to here time t3. So on like that only. But I don't want this one. So I will consider only one arc itself. Right? One sphere. So here also one sphere. Here also one sphere. Here also one sphere. So from here to here distance. Same distance only. So how much distance? So d distance. D distance. Right? So now again I draw common tangent. Common tangent. Is a common tangent is used secondary waves. Is a common tangent. Is a common tangent. Is gives secondary wavelet. That means secondary is a secondary wavefront. Secondary wavefront. So half of the circle. So again here half circle. Here also. Right? So here also. Right? So like that we can form. Right? Are you clear, everybody? So primary source and secondary source. This is the primary wavefront. Primary wavefront is a secondary wavelets. Is a secondary wavelet. This is a secondary source of secondary wavelets. Source of secondary wavelet is the secondary wavelet. Secondary wavelet always sphere. Remember, secondary wavelet is sphere, but wavefront is common tangent. Common tangent is a common tangent. This is the our Huygens principle. Huygens principle is the source of secondary disturbance. Yes, is the source of secondary disturbance. This is the first wavefront. First wavefront, plane wavefront. Remember. So this is the secondary wavefront. Secondary wavefront. What is this? Secondary wavelet. Secondary wavelet. Secondary wavelet. This is now distance from here to here distance d. So v into t1. So nothing but v into tau. So after time t1 seconds. So the wavelet can travel distance is d. This is the plane wavefront. Related topic is the plane wavefront. This is the spherical wavefront. Spherical wavefront. Similarly, cylindrical wavefront also same like that will come. This is the Huygens principle. Did you understand, everybody? So very important concept now. Huygens principle. Right. So now we will discuss next very important topic, that is reflection and refraction. Right. Right, ma. So now reflection. So third concept is what? Reflection and refraction of plane waves using Huygens principle. Very important 3 mark as well as 5 mark question. So reflection is the 3 mark question, refraction is the 5 mark question. First 5 mark question, refraction. That means show that laws of reflections. That means proves laws of reflection and laws of refraction by using Huygens principle. Huygens principle. Okay. So now first I will consider here reflection purpose. Reflection of a plane surface. Reflection of a plane surface. Right. Reflection. For reflection purpose we want to consider which one? Plane mirror. So reflection purpose plane. Remember plane surface. Okay. So plane wave front. We want to consider plane wave front. Plane wave front. Previous also I remember here. What is that? This is a plane wave front. This is a primary wave front. So each point is gives secondary wavelets. Is a source of secondary wavelet. So like that itself. Here also here like that. Here also like that itself. Again. So again here, what happened? So primary, what is that? Is the secondary wavefront. Again, this is the source of secondary wavelet. Again, is the common tangent. Is nothing but so after t2 seconds wavefront. After time t2 seconds. This is third wavefront. Third wavefront. So on like that only will come. Right. Now reflection purpose. I want to consider plane wave. Plane mirror. Sorry. Plane mirror. Okay. So this is the plane mirror. Is the plane mirror. Plane mirror I will consider as a plane mirror M and N. Right. So I also basically remember here. So this is the plane mirror. Plane mirror. So now these are the incident rays. Incident rays is the incident rays. So here if I consider t is equal to 0 seconds, so t is equal to 1 second, 2 seconds, 3 seconds, so on like that only. So now this is the what is that? Incident rays. So here this point I will consider A, this point I will consider B, this point time t is equal to t seconds. That means so it can reach this surface, but this one cannot reach here. So still it can cover some distance from here to here. The light can cover some distance. The light can cover some distance. This one also from here to some distance. From here to here some distance. From here to some distance. From here to some distance only. So now you know already what is that very important point. Very important point I told. What is that? Wavefront is always perpendicular to the propagation of wave. Propagation of the direction of wave. Propagation of the direction of wave. Yes or no? This is the given right point. What is that? So the wavefront always perpendicular. This is the wavefront. Is the wavefront. Is the wavefront. At A, at C, B, C, like that I will get 2 points. So remaining waves I can remove. I don't want. So now I will consider only 2 rays. So 2 incident rays. Okay. So this is the direction of incident ray. The direction of incident ray after time t seconds. It can reach the plane surface. Is the incident ray. Is the incident ray. You also this one also incident ray. But this is what? Is a primary wave front. Primary wave front. This is we will call incident wave front. Remember, no more confusion. This one and this one both are what is that? Incident rays. Incident rays. This is the what? Incident wave front. Incident wave front, and the angle between incident ray and incident wave front is always 90 degrees. Remember everybody, is the 90 degree. Is the 90 degrees. So again here I can draw normal. This is the normal. Normal is always perpendicular to the plane surface. Perpendicular to the plane surface, right? So this is the normal n. Is the normal n. So here to here angle is how much? From here to here 90 degrees. 90 degree. So this angle is how much? Angle of incident. So this is what will come? 90 minus I. Correct or not? So total from here to here is how much? 90 degrees. From here to here angle of incident. From here to here how much? 90 minus I. 90 minus I. Okay. Then next, from normal to this plane surface. Normal to this plane surface. How much? 90 degrees. 90 degrees. Correct or not? So from here to here 90 degrees. So here to here 90 degrees. Right. Now from here to here how much will come? From here to here 90. From here to here is how much? You know this value. This value how much? 90 minus I. So this is how much? 90. This is how much will come? 90 minus I. So 90 get cancelled. This is the I will come. This is the I. That I is known as, so angle of incident. Angle of incident wave front. Angle of incident wave front means angle of incident wave front we will consider as the angle between from plane surface to incident wave front. The angle between the plane surface to is the plane surface. Remember, is the plane surface. This is the incident wave front between angle. This angle is known as angle of incident wavefront. Angle of incident wavefront. Remember. So now this is from here to here distance will come. So how much distance? After t seconds. So distance d is equal to v into t. So distance from here to here how much will come? Here to here v into t. So this angle also how much? 90 degrees. So this angle is how much? I only. Right. So now I told very clearly previous also. Very clear, I told very clearly. What is that? Each point on a on a primary wavefront. Each point on a primary wavefront is gives secondary wavelets. It gives secondary wavelets. Okay, na? Secondary wavelets. Secondary wavelets. So secondary wavelets is look like a sphere only, right? Does it look like a sphere only? That means with respect to A. So here one sphere, right? Here one sphere. Yes or no? Here one sphere. Here one sphere. So like that only. So that means this is the, what is that? Arc is the arc. I will consider. So now this is the incident ray. Now I can draw reflected ray. Reflected ray. This is the reflected ray. Reflected ray is the reflected ray. Is the incident ray. This is the reflected ray. The reflected ray is perpendicular to the wavefront, right? This is the wavelet mean wavefront. That means we can draw common tangent in this manner. Is a common tangent. This is a common tangent is nothing but a secondary wavelet. Secondary wavefront, sorry, not a secondary wavelet. So this sphere is nothing but a secondary, this one, and this one, and this one, and this one. So what is that? Secondary wavelet. So now common tangent. You can draw common tangent. That common tangent is secondary wavefront. Secondary wavefront. Now this is the wavefront. As a wavefront. Me. So this is a reflecting ray. Yes, reflecting ray is always perpendicular to the secondary wavefront. So now I can draw here common tangent in this direction. In this direction. Okay. So this is the common tangent. Common tangent. This common tangent is nothing but reflected wavefront. Reflected wavefront. So from here to distance, how much should be there? From here to here also same distance will come. From here to here, how much distance will be there? From here to here also same distance will come. Same distance. That means this is the VT. This one also VT. That one also VT. Here angle is how much? 90 degrees. Here angle is how much? 90 degrees. So this angle is what? Angle of incident wavefront. Again, this is the reflected ray. Is the incident ray, is the reflected ray. So now I can draw here, this is the normal. Is the normal. Okay, this is the angle of reflection. So from here to here how much? 90 degrees. So this is how much will come? 90 minus R will come. So from here to here how much? 90. So now I want to this one only. What is that? 90 minus 90 plus R will come. So get cancelled. This is the R only. Correct already? So like that will be there. So this is the 90. So this one. Right? This is the 90 minus R. So from here to here 90. This is how much will come? Is a 90. Subtract 90 minus R. So 90 minus plus. So R only. So this is what? Angle of refraction. So this is the I and R. Angle of incident wave, sorry, reflected wavefront. Remember everybody. So this is the incident wavefront. This is the reflected wavefront. Incident wavefront and reflected wavefront. Now this diagram I can draw clearly here. Okay, everybody can observe now. So that is the rough diagram. Now I can draw clear diagram here. So now what is that? So this is the incident ray. First incident ray. Parallel rays. Remember, parallel rays. This is the T is equal to 0 seconds. So now again here one more incident ray I will consider. One more incident ray I will consider. Okay. There is a one more incident ray. This is the after t is equal to t seconds. Alright? Okay. So now I want to draw here perpendicular line. Perpendicular. Yes, is the perpendicular. That means this is the incident wavefront. Incident wavefront is the A and this is the B. So from here to here. So what is that incident wavefront? So remember here AB is equal to incident wavefront. Incident wavefront. Incident wavefront. So here angle is how much? 90 degrees. 90 degrees. Here also 90 degrees. So this is the distance V into T. V into T distance. Distance is equal to how much ma? D is equal to V into T. So now I can draw here normal. Is the normal. Okay. Is the normal N. So this angle is angle of incident I is the incident rays. Remember this is incident ray. This one also incident ray. This is incident wave front. Incident wave front. This angle is how much will come? 90 minus I. So this total angle is 90. So this one how much will come? This total angle is 90. This one is how much? I will come. I give an explanation here already. Right. So next, this A is gives to secondary wavelets. Secondary wavelets. Here one sphere, here one sphere, here everywhere one sphere can form. So that now I can draw here. So secondary wavefront. Secondary wavefront is the secondary wavefront. Secondary wavefront. Here one sphere. Here also one sphere. So this is the, what is that? What is this? Reflected ray. Reflected ray. So again here also is a parallel. Reflected ray. So this is normal. This is the normal. Are you following? This is the normal. So again, so this angle is angle of refraction. This angle is, so you remember here to here how much? 90 degrees. From here to here 90 degrees. This one is how much? 90 minus R. So this angle is how much? This angle is angle of refraction. Okay? This is the I. So this I is nothing but angle of incident wavefront. This R is nothing but angle of reflected wavefront. So this is, remember, this one is what? So I will give you here B. This is the C. Yeah, B I have given, right? So AB. This is, I will consider C. Okay, this is the C here. B I took there. Sorry. So this is the C, and this is the D. This is the D point. This is the C point. This is the reflected wavefront. Reflected wavefront. Reflected wavefront. Remember ma, very important diagram. Reflected wavefront. Reflected wavefront. Correct? Reflected wavefront. It's a little bit. Okay, right. Reflected wavefront. Reflected wavefront. So now, if I observe and also remember, what is that? CB is the reflected wavefront. Reflected wavefront. The distance between from B to C is equal to how much? So D is equal to V into T from here to T also. What is that? Distance d is v into t. And so from here to here, the distance A to B is equal to C to D. CD. The distance of AB is equal to, this is the incident wavefront, this is a reflected wavefront. Correct or not? So incident ray and reflected ray both are meet at same phase. Why? Because there is no difference. Speed is not a different, right? Why? Because the same medium only, na? Same medium. So velocity is same only. So that from here to here distance is same. From here to distance is same one. From that means AB is equal to CD. Similarly, BC is equal to AD. Similarly, what is that? AD is equal to BC. Equal to BC. So now we can observe with help of the diagram. So triangle ABC, triangle BAC. Okay, sin I is equal to opposite side by hypotenuse. This is the common hypotenuse triangle ABC. Similarly, ADC is a common hypotenuse. ADC and ABC and ADC common hypotenuse. This side and this side both are same, and this side and this side both are same. That's what we directly will say. What is that? ABC is congruent to ADC, or else according to sin theta formula. So sin I is equal to this distance. This distance I will consider. So from here to here. So what is that? DC divided by hypotenuse AC. Similarly, triangle ACD BAC over next one ACB. So sin R is equal to now triangle. What is the triangle I took there? So triangle ADC. Sorry, ma, this one. Triangle. What is that? ADC. Sin I is equal to. Okay. Sorry, ma. You can observe here. Triangle ABC. Here sin I. Sin I is equal to opposite side by hypotenuse. So BC by AC. Sorry, not a sin I is equal to BC by AC. BC is equal to how much? V into T divided by AC. Divided by AC. Similarly, triangle ACD. So, with respect to this angle, sin opposite side by hypotenuse. So, sin R is equal to, so what is that? AD divided by AC. AD is equal to V into T divided by AC. So, now we will do sin I by sin R. What will come here? Vt by AC into AC by Vt. So everything is get cancelled. Therefore, what happened here? Sin I is equal to sin R. Sin I is equal to sin R. Or else, so angle of incident is equal to angle of reflection. Correct or not? So this is. So sin I is equal to sin R. Angle of incident is equal to angle of reflection is nothing but loss of reflection. First law over. Correct? That is the first law. So sin I is equal to sin R. So this is nothing but angle of I is equal to angle of R. Mean angle of incident wavefront is equal to angle of reflected wavefront, reflected wavefront. Alright, so this is the reflection, about reflection. Similarly, second law also, incident ray, reflected ray, normal lie on the same plane. Incident ray, reflected ray, normal lie on the same plane. Alright, so this is the reflection, about reflection. Finish. Are you clear, everybody? Remember, everybody. So now the most very simple, but explanation is more will be there, but derivation part is very small. Alright. Is the reflection. Is the reflection. Right. Similarly, I will give you refraction also. I will give you refraction. Right. Right, ma. Refraction tomorrow I will give you. So today, so I have given only Huygen's principle as well as reflection proofs. Okay. So thank you to one and all. So tomorrow I will give you refraction. Right. Thank you. Thank you so much. Okay. Bye.